Here we go. Critical points. Maximums, minimums, point of inflections. All right, maximums and minimums, we know what they are. Okay, but mathematically, I don't know that you've ever thought about it. Looking at a graph, you can tell if something's a maximum or a minimum. But what we want to do is look and see what happens around these points so that we can determine if it's a maximum or a minimum. Now, there's also going to be things called relative maxes and relative mins. And from these, you need to know really what the parent graph looks like if you're going to decide if you have a relative max or a relative min. Okay, so those parent graphs that we've been talking about this whole chapter are really important for you to know. Where are your tails? What does this look like? All right, so critical points are points on the graph. At which you can, that goes with critical points, sorry, which you can draw a horizontal or vertical line tangent to. Now, what does tangent mean? Next to, touching, forming a right angle to tangent, not as in the sine or the cosine in the tangent. Okay? So tangent means touches at one point. All right, so then we have maximums. A maximum is the how do I make it fine? This. Okay. All right, the graph increases to the, is it to the, I have it on here, to the left of the critical point and decreases, CP is critical point, to the right. All right, the graph. When we talk about the graph, we're looking at y values. So the y value is increasing to the left of the critical point and decreasing to the right. So we're going to be observing what's happening to the y values as we look a little bit to the left of our critical point and a little bit to the right of our critical point. Okay? And think about it. Doesn't that make sense? If I have a maximum, my y values are increasing, correct, as I look a little to the left. And then as I go down, my values are decreasing, going down. Okay? All right, a minimum. If it's a minimum, let's look. If it's a minimum, it's a low point. What's happening to our y values to the left? And as to the right? Okay, so the graph decreases to the left of the critical point, CP, and increases to the right. All right, point of inflection. A point of inflection is this. That right there is your point of inflection. What do you think our y values are doing? I could also do it like this, right? What's happening to our y values? Yeah, wouldn't you agree on this one? My y values are continuing to increase. So there's no change, right? And on this one, what are happening to my y values? They're going to continue to decrease on either side of that critical point. Mm-hmm. No. Parabolas don't have points of inflections. They have a maximum. So your choices are a maximum, a minimum, or a point of inflection. Does that make more sense? Allie? Something like this. That's not a critical point, okay? Because I can't draw a horizontal or a vertical line. I can draw a slanted line. It's going to be tangent, but it won't be horizontal or vertical. It's not going to. It's going to touch it. So, I mean, I could, on this one, at this point, I could draw kind of a line tangent, but it's not a horizontal or vertical, and that's what defines it, that the line that we draw is either horizontal or vertical. Okay? All right, so here, there is the graph changes curvature. And so the y values either continue to increase or decrease on either side of the critical point. So remember, we're looking at our y values as we do this. All right, so an absolute maximum. Graph that looks like this. Okay. I have two maximums, don't I? I have a maximum at this point and at this point. But an absolute maximum is the only y value that will, it's the largest one that exists on that entire graph. Okay? So this is the largest y value that exists over the graph's domain. Whereas the absolute minimum, again, I have several minimums, but the absolute minimum is then the what y? Okay, think mathematically. Yes. Okay, it's the smallest y value over the graph's domain. Or I should say the function's domain. Okay? Okay. Relative max and relative mins. Why would this be considered the relative maximum? Yeah, look at your tails. Do you see that y's continue to get larger as our graph goes, as our x values go to in positive infinity? Our y values will continue to get larger and larger. So this is a relative maximum of the graph. Something's happening there, but it's not the absolute maximum. Does that make sense? It is not the greatest because the y values continue to increase. Likewise, this is the relative minimum because of our tail going down. It implies that our y values will continue to get smaller as our function goes towards negative infinity. So this is a relative max and relative min. So the relative max is not the greatest. Y value. And this one is not the smallest y value. In each case, it's over the domain. Bless you. Okay, yes, ma'am.
So, you're going to have like a relative maximum or minimum if you have an I function.
Perfect. Yep, I think that's a good way to say it. Okay. Okay, so let's see how we show this. This is the table method. Okay. Over here are your critical points. And what we're looking at is what happens to the left and to the right of our y value. As we plug in our critical point and we subtract 0.1 and add 0.1, so we're approaching our x value from either side, correct? Kind of what we did yesterday. What is happening to our y values? That's what we're looking at. So we're concerned about what's going on here, here, and here. Are our numbers increasing and then decreasing, or are they decreasing and then increasing? Okay? And then here you're going to write, well, I've got a max or a min, some type, either relative or absolute or inflection. Yes?
Can you just have like the regular
Yeah. Usually they're, I mean, if you know it's absolute, then put an absolute. Okay. If it's not absolute and it's not the relative one, then you can just put max or min. I know the book sometimes just puts max or min, which is a little bit confusing. Okay. So this says 2x to the what? Is that a 6 or a 5? Do you think it's a 5? Okay. Minus 5x to the 1, 4, minus 10x cubed. So in your mind, what does this look like? Where are the tails? Odd and positive. So we're doing something that looks like this. So we got lots of loopies, though, going on. Okay? You know, I'm just doing a sketch to show you your tails, but we could have more than one hump going on in the problem. All right, I'm telling you that there are critical points at these values, -1, 0, and 3. And so we're going to put -1. We'll look at that one first. Okay, and so the way I set this up is if my x is -1, then 0.1 to the left is -1.1, right? We will. I'm not there yet. And a little bit to the right of -1, because remember we're looking at what happens to the left and to the right of this critical value of x. We're going to get what? -0.9. Now we're going to plug these values in. Okay? What is f at basically -1.1? What's at my function at -1? And what's my function at -0.9? Well, plug it in. Use your calculator. What do you get? Let's see what's going on. Here you should get 3. All right, Maggie, what'd you get here at negative 1.1? That's not what I got. I got 2.768. Okay. Over here, what do we get? I got 2.998. Would you anybody else get what Alex got? What'd you get? Okay. So you got to think about what this is doing. Think about your y values. At negative 1, and the beauty of finding these critical points is it's allowing you to actually grasp this more clearly than just telling me where the tails are. Okay? I'm telling you my graph is doing something weird at negative 1, 0, and positive 3. Okay? We know because our coefficient is positive and our exponent is odd that our tails have to end in the first and the third. Okay? But at negative 1, I am at 2. Well, at negative 1, I'm at 3. And at a little bit to the left, I'm a little bit down. And at a little bit to the right, I'm a little bit down. Right? If you can't see it, plot it. All right? So what do you think's going on here? So what are we doing? We know this tail is coming from here. We don't have any other critical points. Well, we don't know yet. Let's see what our other critical points do. But would we agree? Would this be a max, a min, or a point of inflection? It's max, okay? So we don't know what kind, but we're going to say max. All right, now we're going to try another point, which is 0. So a little bit to the left of 0 is negative 0.1. A little bit to the right of 0 is positive 0.1. And we do this process all over again. Well, at negative 1.1, which is a little bit to the left of negative 1, I'm at 2.768, which is just under 3. Better? Okay, so what did we get at negative 0.1? 0.009. Okay, so let's graph it. A little bit to the left, we're just a little bit above 0, correct? Yes? Okay, we move to the right, what do we get? Negative 0.01. So at a little bit to the right, we're down in the negative zone, aren't we? So what do you think's going on here? It's an inflection, right? Wouldn't you agree that our point starts at positive 0.09, then down to 0 is our y value, and then down to the negative zone? So it's an inflection. Okay. Remember, we're trying to draw that. That means it changes curvature, right? So that means it's coming down, and now it's going to do something like this. Okay? It's going to go from going this way to going this way. Just change its curvature a little bit. Okay? All right, do the last one yourself. Maggie, are you getting the right answers now? Right numbers? Okay. Once you go. Okay. Okay. You getting the same values that I'm getting? I got negative 187.3 to the left and negative 187.09 to the right. So we're dealing with negative numbers. Don't forget your feeling of what numbers are doing. So a little bit to the, and this is at 3, right? A little bit to the, at 3, we're at negative 187. A little bit to the right, we are where? A little bit below this point or above? Oh, this is 187. This is 189, I mean. So where is negative 187.3? Above, right? Isn't this about negative 187? So we are a little bit above on both sides of that critical point, aren't we? So look, we've got that point of inflection. We come down, and guess what? We go back up. Isn't this the way it's supposed to look? Didn't we say that the tails had to be in the first and the third quadrant? All right, so this is what? This last one is what kind of a point? I'm sorry, I can't hear you. It's a minimum. So let's be specific now that we have what this graph looks like. Maximum, absolute maximum, relative maximum. Why would you say this is absolute? Who says it was absolute? But look at your tail, Larissa. Remember, who said this? I forget who said this. Maybe you did. Yeah, if it's even, you're going to have absolutes. If it's odd, you're going to have relatives, aren't you? Because your tails continue to go in either direction, okay? So these are both relative, but we've drawn the graph, okay? Because we're looking at what happens as our graph approaches. So we're looking at limits. We're not calling them limits, but this is what a limit is. What happens a little bit before one point and a little bit after that point? What is a point approaching? What is your y value approaching? Hmm? The limit does exist. Okay, so let's do an extension of yesterday. So how is our function increasing and decreasing? So give me your intervals. This was on your homework. This will be on your quiz. I'm not asking for what my tails are doing. You're supposed to tell me when my function is increasing and when my function is decreasing and when my function is increasing. Okay, what about -1? If x, so we've got, if x is less than -1, function is f of x is increasing. Okay, that means we've taken care of everything from this little humpy here where it's changing to the left, right? Isn't our function increasing? Aren't we going up the hill as we read from left to right? Okay, now it's decreasing. It's going down. Between which interval is my function decreasing? -1 and? No, because it's continuing to decrease. It's just doing a little inflection. -1 and, where does it turn around again? And 3. Remember, it's your x value that you worry about. You talk about whether your function increases or decreases according to the x value. That determines your intervals. So between -1 and 3, my function is now decreasing. Okay. What do I do now? Okay? We're not very sure on this. Okay? Maybe what you should do is put a little lines down when you're trying to figure out your increasing and decreasing. So you see to the left of that dotted line what's going on. In between those dotted lines, what's going on. To the right of that dotted line, what's that function doing? Okay? We don't care about the y value for this part of it. We are interested in the x value because that defines the interval that the function increases or decreases. Okay, here we go. My critical points are at 22 and 46. I'll always give you your critical points right now. Okay? So my critical points are 22 and 46. A little bit before 22 is 21.9. A little bit to the right is 22.1. At 22, figure all this stuff out. This is what, even or odd? Where are your tails? So, where are your tails? Okay, so we'll probably have what kinds of maxes and mins? Relatives. See how we're tying this all together? That's what I have down from last year. Does that make sense? Are you getting the same answers or not? That's fine. If you're like a decimal off, as long as you're, I carried out more than I would rounding because sometimes taking it out a few decimal places, then you can see more clearly. I mean, if you notice, I'm pretty close, aren't I, on that first line? What do you have at f of x? Because this isn't going to work out right. What do you have? Oh, then that's what I'm writing. I couldn't read this because it was thicker. Is it 0.21 on each one of these? Okay, good. Because otherwise I'm thinking that's not going to work. So 2-1. That's 2-1. To me, I couldn't read my own handwriting. Yes, now that works. Hmm? Some really odd, large numbers. Ugh. And I would like you to sketch a little bit of the graphs, even if it's just like what I did, which is kind of approximating where the numbers are because they're so huge. Okay? So what do you think 22's critical point is? What do you think it is? Yeah. Relative max. We're not going to have absolutes because our tails continue on both directions. What is the critical point at 46 going to be? Relative min. Okay. Let's talk about what our function is doing. Let's go ahead and draw these little dotted lines if it's going to help y'all. Okay. How would we describe our function in terms of increasing and decreasing? What would you say? Who wants to give this one a try? All right, Larissa? So we're going to say f of x is increasing. Good. What else? Who else can tell me an interval? Maggie?
22 less than x less than 46. Oh, wait, would be greater.
Yeah, I got it. I knew what you're saying.
And then it would be decreasing.
Function is decreasing because we're going down the hill. We're sliding down. And what's my last interval going to say? Katie? The function is increasing. But I took it. Did y'all see me take it? And then I sent you an email that said, oops, I forgot Lindsay Duran, so she's the only one. Understand what I do wrong. I can never get 8 A's right. I'm always taking this thing wrong. Okay, you do this next one all by yourself. Tell me the kind of critical point at 4.5. Sketch the graph and tell me what your function is doing to the left and to the right of that value. What should this look like? What is the highest degree? It's a parabola. Highest degree is 2 squared. Okay. So you do this one yourself. But look at x squared is negative. right? We got to look at our x squared term. Okay, so it's pointing down, and it's an absolute max in this case because it's got tails going in both directions. Never will you have a value greater than that value. Okay? All right, name and classify the extrema for the graphs. So we have to locate these values, and we're talking about our x values when we define them. So when x is equal to -3, that's our first extrema, not our y value, but our x. What do we have? What kind of minimum? Is it the lowest point on the graph? Then it's a relative minimum. Okay? When x is equal to 1, what do we have on our graph? A relative max. Because our tails are going up forever, which means that is just a relative maximum. It's a place where our graph is turning. And at x is equal to, what is that? 1, 2, 3, 4. 4. What is going on? What kind of minimum? This is an absolute minimum because never is the graph any lower than that point. Does that make sense? Who's getting confused about relative or maximum? Okay, you try the next one. Okay, so at x equals -2, Megan, what do I have? A relative minimum. At x is equal to 3, Courtney, what do I have? No, it'll be a maximum. It's a relative maximum. Because the graph totally turns and goes in the other direction. A point of inflection means it continues on in that direction. Is that better? Okay. All right, are we good? Got it? Okay. So find your homework, do day 1, please.